This demo video describes how to experimentally determine the melting point range of organic solids. Specifically, how to prepare a sample for analysis, how to prepare a sample for a so-called mixed melting point range analysis, which is a technique used to establish the identity of a solid, and the use of the Mel-Temp apparatus, which is the apparatus we use in our labs to determine melting point ranges. We'll start with how to prepare a sample for melting point analysis. You must place the solid sample in a melting point capillary tube, which is a thin glass tube, 90 millimeters in length, with one end open and the other end sealed. You need to place an appropriate amount of sample at the bottom of this closed-end tube. What's an appropriate amount? What's shown here is way too much sample. This photo shows the maximum amount to use. A sample height of 1 to 2 millimeters should suffice. You can load the tube as follows. The sample should be powdered so that it can easily slide down the tube. If your sample consists of large chunks, grind it into a powder before proceeding. The sample to be analyzed can be placed on weighing paper or in a weighing vessel, but for stock samples stored in label dispensing bottles, you can push the capillary directly into the solid sample in the bottle without transferring the solid to weighing paper. Since you always use an unused clean capillary tube, you won't be contaminating the stock sample. Invert the capillary and push it into the solid sample a very short distance so that you capture a small plug of sample, about 1 to 2 millimeters in length, at the opened end. With the closed end of the tube placed downward, grasp the tube between your thumb and forefinger with the tube bottom flush with the bottom of your thumb and forefinger. You do this so that when you gently tap the bottom of the tube on the bench top, your thumb and forefinger absorb the brunt of the force so that you don't break the tube. Please note that the tubes are fragile and you can easily cut yourself on broken fragments. Here is demonstrated how to place a solid into a melting point capillary tube. This is the sealed end in which the sample will eventually be placed, and the solid enters through this opening. The sample being analyzed is transenamic acid, which has a reported melting point range of 132 to 135 degrees C. It's already powdered, so the capillary can be inserted just deep enough to capture a plug of sample of approximately 2 to 3 millimeters at the opening of the tube. Don't pack too tightly or the solid will remain jammed and won't move down the tube. Take the capillary between your thumb and forefinger and gently tap the bottom of the capillary on the bench top to make the solid fall to the closed end. A piece of weighing paper catches any solid that falls to the bench top as you do this. The sample is now ready for analysis. Mixed melting point range analysis is often used when either identifying an unknown solid or confirming the identity of a solid. This technique involves mixing together small amounts of two solids and then experimentally determining the melting point range of the resulting binary mixture. What follows is a demonstration of how to prepare that mixture and then transfer an appropriate amount to a melting point capillary tube. In this demonstration, the two solids to be mixed are transenamic acid and urea. Both have reported melting point ranges of 132 to 135 degrees C. Start by placing a very small amount of one of the solids on a piece of glassine weighing paper using a clean spatula. Remember to replace caps on stock bottles when you're finished using them, and always clean the spatula with tissue or paper towel before using it to transfer the other solid to avoid contaminating the stock bottle. Now transfer an approximately equal amount of the other solid onto the weighing paper. Don't worry about getting exactly equal amounts. Approximate amounts are fine. Remember to once again replace the cap on the stock bottle, and remember to clean the spatula. Now, fold the weighing paper in half over the two solids. Use either a scupula or a spatula and apply the force of a thumb or forefinger to crush the two solids together so that they're thoroughly mixed. Obtain a clean, unused melting point capillary tube and prepare a sample for melting point analysis as you did before. If simply pushing down on the mixture of solids doesn't capture a plug of solid at the tube opening, push down on the solids with a twisting motion, which should force solid into the tube opening. Tap the tube bottom on the bench top as you've done before to make the solid fall to the closed end of the tube. The mixture is now ready for analysis. Once you've prepared your samples in capillary tubes, you can place them in the Mel-Temp apparatus to experimentally determine their melting point ranges. This is the Mel-Temp apparatus. Up to 3 capillary tubes can be inserted into slots located above the viewfinder, which is a magnifying lens that allows you to observe the melting process on very small amounts of sample. Each apparatus is equipped with a digital thermometer. When you turn it on, remember to check that it's set to degrees Celsius, and please also remember to turn it off when you're finished. A built-in voltage regulator is used to control the rate of heating. You'll adjust it to a setting that provides an amount of electrical current that causes the temperature of the apparatus to rise no more than approximately 2 degrees per minute as your sample melts. To avoid misidentifying samples, please remember to label them either with labeling tape or by marking the capillaries with a permanent marker. To analyze samples with the Mel-Temp apparatus, turn on the thermometer and check to see that it's set to degrees Celsius. Now turn the power switch to the on position. You'll notice the sample area will become illuminated. Place up to 3 melting point capillaries containing sample into the sample slots located just behind the viewfinder. Set the voltage regulator to an appropriate setting and monitor rise in temperature as you incrementally raise the voltage regulator settings throughout your analysis. Remember, the higher the power level setting on the regulator, the faster the rate of heating. Please also note that the regulator scale on some of the older models we have is 0 to 100 and not 0 to 10. So a setting of 30 on older models equals a setting of 3 on newer models. When you know the melting point range of the solid you're analyzing and it's somewhat high, say greater than 100 degrees Celsius, you can start with a regulator setting of 3 or 4 so the temperature raises rapidly at first so you don't waste time. The rate will eventually slow down, remember, and level off if you don't raise the regulator setting any further. Then continually raise the regulator setting in small increments while monitoring the temperature registering on the thermometer, and your goal is to achieve a rate of increase at the point of melting of approximately 2 degrees per minute. When you don't know the melting point range of the solid that you're analyzing, for example, it's an assigned unknown, it's recommended that you perform 2 melting point determinations on that compound. The first is a quick ballpark melting point range determination by rapidly heating a sample to its melting point range. You don't know if this sample melts at 50 or 150, so in order not to waste time, you're sacrificing a small amount of sample to quickly get a rough idea of the temperature at which you would expect to see melting begin. Discard this sample in a glass waste container when you're done. Then you'll make a fresh sample in a capillary, and you will perform a slow, accurate melting point determination. If the expected range is high, start with a regulator setting of 3 or 4. If the expected range is low, you can start with a lower regulator setting. As before, continually raise the regulator setting in small increments while monitoring the temperature on the thermometer to achieve a rate of increase at the point of melting of approximately 2 degrees per minute. Why is it so important that the rise in temperature be slow at the point of melting? This gives time for the thermometer to equilibrate with and therefore accurately measure the temperature of the Mel-Temp's metal sample block. And it's that metal that is heating your sample in the capillary. Therefore, the thermometer will correctly register the actual temperature the sample is feeling, and you'll observe an accurate melting point range. If you heat the sample too fast, that doesn't give enough time for the thermometer to equilibrate with the metal of the Mel-Temp. Therefore, the thermometer temperature will always lag behind that of the metal of the Mel-Temp, and you'll observe an artificially low melting point range. Whenever you're determining melting point ranges, it's recommended to always make small increases in the setting of the regulator and to avoid going from high to low settings. Remember, when increasing the setting, you have control over the rate at which temperature rises. However, when you decrease the setting, you have no control over the rate of cooling. Lowering the setting will not instantly cool the apparatus. In fact, it will probably still rise in temperature for several minutes, and you will not know when the temperature levels off so that you can begin to raise the setting once again. As you slowly raise the temperature of the apparatus, what you'll see through the magnifying lens of the viewfinder is the solid in the capillary beginning to shrink or change shape, and it might also glisten or appear to sweat, but that's not the start of melting. As the temperature continues to slowly rise, the first appearance of an actual liquid signals the start of melting. Record that temperature in your notebook. More liquid will continue to appear, but some solid will still be visible, and eventually, at a specific temperature, only liquid will be present. Record that temperature in your notebook as well. Use those two recorded temperatures to report the melting point range. For example, if the melting process began at 120 degrees and was complete by 121 degrees, you would report the melting point range as 120-121 degrees Celsius. We're looking through the viewfinder as a sample of pure transenamic acid begins to melt. It starts out damp and glistens, but liquid only begins to appear at 133.5 degrees. At 134 degrees, a liquid meniscus is apparent, but solid is still present. It's not until the temperature reaches 134.2 degrees that only liquid is present. The reported melting point range for this sample is therefore 133.5 to 134.2 degrees C. Please remember that you're using a shared workspace. When you're finished, please remove all used capillaries from your work area and place them in a glass waste container.